In the previous video I showed you how to calculate the x and y coordinates of intersections on parts that have open and closed angles. Now it was a challenge to find the triangles necessary to calculate those distances, and the next challenge is to know what formula to use to calculate the lengths of the sides of those triangles. So what I want to do in this video is just kind of go over the basics of right angle triangles and then show you 6 formulas to remember to calculate any lengths of the sides. Alright, so we're looking at a right angle triangle here, and what makes up a right angle triangle is that one of the 3 corners is 90 degrees. So I got this little square right here, and that means that this is 90 degrees. Now the sum of the 3 corners on a right angle triangle will always add up to 180 degrees. Alright, so we already have 90, and let's say that this is 30 degrees right here, this corner. That means we have 30 and 90, so we have 120 so far. So that means we have 60 left. So that automatically means that this corner is 60 degrees. Okay. Now we have 3 sides to the triangle, and the long side right here is always going to be called the hypotenuse. And then let's say that we are working with this 30-degree corner right here, then this leg would be considered the adjacent, and then this opposite leg of the 30 degrees would be called the opposite side. Okay, so we have the adjacent, the opposite, and the hypotenuse. So right now we're working with this 30-degree corner, so therefore the leg that is attached to the 90-degree corner will be the adjacent, and then the leg opposite of that corner obviously will be the opposite leg. Okay, now the long leg opposite of the 90 is always going to be called the hypotenuse. Alright, so let's do our first calculation. What we want to find out is what is the length of the opposite leg right here, and the known dimensions we have right now is this 30 degree, and then the hypotenuse is 3 inches. Okay, so the length from here to here is 3 inches. And we want to know what this distance is. Okay? So, in order to do our calculation, we have to have 2 known dimensions. Alright, so we got the 30 degrees and we have the 3-inch length on the hypotenuse. So for this particular calculation, we're going to say O, which is the opposite leg, equals the sine of 30 degrees multiplied times the hypotenuse. So the H is the hypotenuse and the O is the opposite leg. Okay? Alright, so now why did I pick sine? Well, the corner that I'm using, if I know the length of the hypotenuse, then I'm going to use the sine of that corner and multiply it times the length of the hypotenuse, okay, to find the opposite leg. Alright, so we get the calculator out. We're going to click sine of 30 degrees equals, and that is 0.5. So equals 0.5 multiplied times the 3 inches. So that is 1.5 inches. So the opposite leg is 1.5 inches. Okay? Alright, with that same information I can also find what the length of the adjacent leg is. Okay? So I'm going to erase this formula right here. And with the same information that I have here, the hypotenuse being 3 inches, I can calculate what the adjacent leg would be. So in this case, the adjacent leg, so that's the A, equals the cosine of 30 degrees multiplied times H. So that equals, we take our calculator, I'm going to clear this. I'm going to take the cosine of 30 degrees equals 0.866, and we're going to multiply that times that 3 inches. So we're going to multiply that times 3 equals 2 inches 598. Okay? So that is the length of the adjacent leg right here. Alright, then there's one more I want to cover with you, and that is using the tangent. So far we've used sine and cosine. So let's say that we have this length right here, the 2 inches 598. We don't know the 3 inches, but we're going to use this length right now to find the opposite leg. Okay? So we still have our 30-degree corner, and we have this 2 inches 598. So with these two pieces of information, we're going to find out what the length is of the opposite leg. So for that calculation, we're going to use O equals the tangent of 30 degrees multiplied times the adjacent leg. Alright, so that equals, we'll go back to our calculator, tangent of 30 degrees equals, and that is 0.577 rounded off, times the adjacent leg, which is 2 inches 598. So times 2 inches 598 equals 1 inch 4999. So that is pretty close to what our calculation was using the hypotenuse and the sine calculation. Okay, we came up with 5. This is 1.4999, and that's because I rounded off this number, so therefore we're just a slight bit off. But you can see that is pretty close to the same answer that we had using the hypotenuse. Alright, so up to this point we have worked with this 30-degree angle right here, and we assume that we know the distance or the lengths of these legs to be able to calculate the opposite leg right here. Now let's say that we're going to be using this 60 degrees to do the calculations. Now when we were using this 30-degree corner, then this leg, which is attached to the 90-degree angle right here, this leg was the adjacent leg, and then opposite of this corner was the opposite leg. So now if we're going to be using the 60-degree corner, then this becomes the adjacent leg of that corner. So we're going to erase all this. So now this becomes the adjacent, and this becomes the opposite if we're using this angle or this corner instead of this. So I'm just going to erase this so we don't get confused. Alright, so the three formulas that we just learned about still apply the same even though we're using this corner now. Alright, so with this known angle or known corner of 60 degrees and a 3-inch long hypotenuse, we can still use the same formula that we used earlier. So to find opposite, we're going to take the sine of 60 degrees and we're going to multiply that times the hypotenuse. So again, O equals, I'm going to get the calculator out again, and we're going to take the sine of 60 degrees equals, so that is 0.866, and we're going to multiply that times the hypotenuse, so that's that 3 inches equals, so we're going to do times 3 inches equals 2 inches 598 again. Okay, so again we come up with 2 inches 598.
So you can see that it worked the same way as if we were using this corner here. So here again we used the sine of 60 degrees, multiplied it times the hypotenuse to find the opposite. Alright, so let's erase this. Alright, so next, to find the length of the adjacent leg, we take the cosine of 60, so adjacent equals the cosine of the 60 degrees that we know, times the 3-inch h. So that equals, let's clear this, we're going to take the cosine of 60 equals, so that is 0.5, and multiply that times 3. So again, that is 1.5. So again, we'll come on up with 1.5 for this length right here. Okay, so you can see it works out exactly the same way. Now that we're using this corner, this is the adjacent, that becomes the opposite leg, and the formulas work the same way. So all we got left then is the tangent. So let's erase this. So if we want to find the opposite, then we take the tangent of that 60 degree corner and we're going to multiply it times the adjacent. Alright, so we take the calculator, we take the tangent of 60 degrees equals, so equals 1.732, and we're going to multiply that times a, the adjacent, which is 1.5. equals, so we multiply that times 1.5 equals, and here's our 2 inches, 598 again. Okay? Alright, so when you're looking at your triangle, always determine what corner is known, what angle is known. Then once you know that, determine the adjacent and the opposite leg, and then use one of these 3 formulas to calculate the lengths. Next we'll cover, if you don't know the angles, but you have 2 sides, 2 known sides, how to calculate the length of the third leg. Let's take a look at that. Alright, so we're back to our basic right angle triangle, and we're going to keep the naming convention the same. The long leg we're going to still call the H for hypotenuse. The bottom leg here we're going to call the adjacent leg, so A, and then the opposite leg, O. Now these are the 3 formulas we're going to be covering. So this time we're going to learn how to find the length of one of these sides without knowing the angle of one of these 2 corners. Now we always know that the square corner is going to be 90 degrees, but without knowing one of these, we're not able to apply the previous 3 formulas that we learned. Alright, so let's say that we want to find H and we have the length A and O. So A, let's say, is 2 inches and O is 1.5 inches. Okay, so we're going to plug these numbers into this first formula. We want to know H, so H equals the square root of A squared plus O squared. So it's going to be 2 inches squared plus 1.5 inches squared. Alright, so let's plug that into our calculator. So we take the square root of 2 inches squared plus 1.5 inches squared equals 2.5 inches. So H is 2.5 inches. Alright, so now let's say that we need to find A, and we have H and O. We have the 2.5 and we have the 1.5. So we need to find A. So we're going to take the square root of H, the hypotenuse squared, so 2.5 squared, minus O squared, minus 1.5 squared. So back to the calculator. We take the square root of 2.5 squared minus 1.5 squared equals 2 inches. So we're back to 2 inches. Alright, so we got one left, O, is the square root of h squared minus a squared. So let's say that we don't have this. We use this formula to find the opposite leg. And first thing we're going to do is take the square root of 2.5 squared minus 2 inches squared equals back to 1.5. Alright, so one simple way to remember that, if you want to find h, which is always going to be the longer leg, then you're going to add the adjacent and the opposite squared, okay? If you want to find the a, it's always going to be a minus o, and if you want to find the o, it's going to be h minus a. So the only time you're adding is when you want to find the hypotenuse, okay? For the other two, you're going to take the hypotenuse and subtract either the o or the a. So I'm going to stop right there. I hope that simplified it for you a little bit. I thank you for watching, and we'll see you in the next video.